Solutions of the pleasant fraction problem are x over y is greater than 0, x plus 4 equals y, so x over x plus 4 is greater than 0, and x minus 1 over y minus 1, or x plus 3, is greater than or equal to 1 over x. First problem in the pleasant fractions problem is, among all pleasant fractions, is there one with a smaller numerator than any other? If there is one, what is its value? Again, these are the restrictions, and we need to keep these in mind to solve this problem. So I'm going to start by doing x over x plus 4 is greater than 0 and making cases. So case 1 is x is less than 0 and x plus 4 is less than 0. And that makes x less than negative 4. The second case is x is greater than 0 and x plus 4 is also greater than 0. Oops. And so x is greater than 0. It has to be like this because either x and x plus 4 have to be negative so that they become greater than 0, or they both have to be positive. So we're just gonna start by solving case 1 because we are looking for the smallest numerator and it does not have to be greater than 0, so a negative number is less than 0. For the numerator at least. So case 1, x is less than negative 4, x minus 1 over x plus 3, because now you use the problem that you're using to find before, and you cross multiply, so x times x minus 1 is greater than or equal to x plus 3. And that is x squared minus 2x minus 3 is greater than or equal to 0. And its factors are negative 3 and negative 1. So you set it up like that. And x is less than or equal to 3, or x is less than or equal to negative 1. Looking for the negative number that is also less than 0, and both of these numbers fit in the case, you get x is less than or equal to negative 4. The fraction problem is, among all pleasant fractions, is there one with a larger numerator than any other? If there is one, what is its value? So this time we're going to do similar to the first problem. So x minus 1 over x plus 3 is greater than or equal to 1 over x. And then we are going to make them have this common denominator so that we can work with them better. So you need to multiply this side by x plus 3 because the smallest common denominator is x times x plus 3 because each has a different denominator. And so then you're going to multiply this side by x. And you can do this because x plus 3 over x plus 3 is 1, and x over x is 1 also. So you know that you can leave it like that. And then x squared over x squared minus x over x times x plus 3 is greater than or equal to x plus 3 over x times x plus 3. And then you know that you can get rid of the denominator now because this numerator will always be greater than this numerator no matter what the denominator is. So you can forget that for now. So x minus x is greater than or equal to x plus 3. And we're going to subtract this side so that you get 0. So x squared minus 2x minus 3 is greater than or equal to 0, and you get the factors x plus 1 and x minus 3 are greater than 0. So x equals negative 1 or 3. And since we did this and didn't use cases, we can plot it on a number line. So 0 points, so 0 and then negative 1, 1, 2, 3. And both of these are shaded in because it's greater than or equal to. And then you can choose a point here, but you can't choose 0 because that is stated in the domain as not being a viable x. You're using a number line, and their intervals, you use a test point to make sure. So I'm going to use 2. So the original equation is x, so that's 2 minus 1 over 2 plus 3 is greater than or equal to 1 over 2. So this is 1 and this is 5. Fifth is not greater than or equal to 2, so you know that neither of these will go in this area, so they both are shaded out. And you're looking for the highest numerator, so then x is greater than or equal to 3, and so x will continue getting larger as it approaches infinity. Problem 3 of the pleasant fractions problem is among all pleasant fractions for which the numerator is positive, is there one with a smaller numerator than any other? If there is one, what is its value? So with this one, we are going to revisit problem number 1, where we had the two cases, and this case was for both x and x plus 4 to be positive. So we're going to use x is greater than 0 because that fits both of these, and it outweighs x is greater than negative 4. So we're going to set this up as case 2, and that is x over x minus 1 over x plus 3 is greater than or equal to 1 over x. And that equals, because you're going to cross multiply now, that's x times x minus 1 is greater than or equal to x plus 3. And then that turns into x squared minus 2x plus 3 is greater than or equal to 0. So the factors are x minus 3. Oh, I'm sorry, this is actually minus 3 up here. And that makes the factors the same there too. And then x plus 1 are greater than 0. And so x plus 1 is greater than or equal to 0, so x is greater than or equal to negative 1. And x minus 3 is greater than or equal to 0, so x is greater than or equal to 3. So this is the first positive one, and also from the second problem, you know that there are no x values between negative 1 and 3. So you know that x equaling 3 is the first and smallest x that is positive.